Hi, intermediate algebra students. It's time for another lesson online. This one on 12-4 dividing polynomials. And notice the spiffy black background. We'll see how that works today. Well, there's really two parts here, two approaches we have to dividing polynomials. One is when we divide a polynomial, and again, a polynomial, you remember, is more than one term, so this would be a polynomial. And if we divide it by a monomial, remember a monomial is just one chunk of numbers and or variables. Anyway, if we do this, if we're just dividing by a monomial, what we can do is write that same monomial underneath in a series of fractions. So really what this will end up to be is 2x squared minus 8, and then I'm going to divide each of these by that 4x. So I really have two different fractions here, and then maybe I can do some reducing or canceling here. Notice in this case 2 goes into 4 twice, and x will go into x squared. Well, there'll be one x left over. Same thing here, 4 goes into 8 twice, and then I have 2 left over. So really what this is going to end up equaling when we're all done here is x over 2 minus 2 over x. And that's really the best we'll be able to do at this point. Alright, let's another one of these. Here's the same type of approach. Again, since we're just dividing by a monomial like that, I'm going to use that same approach that I did before. So I'm going to essentially, and I'll do a little shortcut here, I'll just put this 4x underneath each of these other terms here, and then we'll just try to simplify each one if we can. So I'm going to get a different color here. So again, 4 into 10, I can divide 2 into each of those, so I get 5 there. One of the x's can cancel out, so I still have an x up here. I can divide each of these by 4, so I get 2. The x's themselves will cancel out. I can divide this by 4, so I have a 5 up there. I still have an x down there. So it looks like my final answer here would be 5x over 2 minus 2, or 2 over 1, plus 5 over x. So that's the best I can do really on those kind of things, and that's pretty easy, I think, when we're dividing by just that one term by that monomial. Just write it underneath each of those other terms and go from there. Now we get to a little bit tougher situation here now when I'm dividing a polynomial by a binomial. Binomial, remember, would be two terms like this. Now, one approach that we can have used to do this is just think back to our factoring methods before. What we're really saying here is that I have this x plus 1. I'm going to multiply it by something, and I'm going to end up with that x squared minus 4x minus 5. And we can kind of think about what we might use here. Obviously, to get that x squared here, it's probably going to be x, because x times x is x squared. And in order to get this negative 5 at the end here, and I'm multiplying it by 1, it pretty much has to be minus 5 like that. And I could go ahead and FOIL this out, use my double distributive property, and we would see that indeed this is the right answer, x minus 5. So that's one approach to doing these, is just to try to use your distributive property in reverse, in a sense. Okay, now there's another opportunity to do this, and this is going to be some long division. And you might remember doing long division from when you were in elementary school. I don't know if they still do that or not, but probably. Let's just review that on an actual number like this. So if I have 560 divided by 9, I'm going to write the bigger number inside these brackets like that. I'm going to divide by 9. And then I ask myself, well, does 9 go into 5? No. 9 goes into 56 how many times? Well, you might remember that 9 times 6 is 54, so we multiply it like that. We end up subtracting. 5 minus 5 is nothing. 6 minus 4 is 2. Bring down the 0. Then I repeat that process 9 goes into 20 2 times. 9 times 2 is 18. And I subtract like that. 9 doesn't go into 2, so I say that 2 is a remainder. So I say 62 remainder 2 would be my answer. Or another answer would be 62, and then I might say plus 2 ninths. The 9 comes from what I am dividing by, like that. That's just a quick review of doing it with numbers. Now let's see what this might look like with polynomials. This is the same one that I did before, but I'll try doing it with this long division method. So let's try that. So I have the x squared minus 4x minus 5. I'm going to divide it by x plus 1. Now I'm always trying to, in a sense, kind of knock out this leading term here. So I ask myself, what would I multiply x by to get x squared? And your answer, of course, would be another x. So now I really have to do the distributive property. So x times x is x squared, and x times 1 is 1x. And I'm going to subtract once again. Now it's a little bit tricky to subtract these, so we have, maybe a good strategy here. You might recall that subtracting is adding the opposite. So I'm going to make this a negative and this a negative, and now I'm just going to add these up again. So now when I add them up again, x squared and a negative x squared, those cancels out. Negative 4x and negative 1x is negative 5x. Then I bring down the negative 5 there again. So now I ask myself, what do I multiply this x by to give me negative 5x? What do I multiply this by to give me that? And sure enough, my answer should be negative 5. Now I multiply negative 5 by each of these. So negative 5 times x and negative 5 times 1. You can see that these are exactly the same, so I'm going to get an answer like that. All right, kind of strange. Another example here and see what we can get here. So this is one we're going to try doing that same particular way here. Let's see what we do. So I'm going to write this as b squared minus 5b plus 6. I'm going to divide it by this b minus 2, and we'll just see what happens here. Once again, this is probably going to be a b up here, b times each of these, so I'm going to get b squared minus 2b. Now I'm going to do a little subtracting once again. When I subtract, I like to change my signs, so now this is going to turn into a plus sign because I changed it. And then when I do that, my b squareds cancel out. Negative 5b plus 2b is negative 3b. And then there's the plus 6 again. And so then what do I multiply this by to get that? I'm going to say minus 3. So minus 3b plus 6. Sure enough, there's my final answer. And so my actual quotient then is b minus 3. Okay, last slide we're going to take a look at. Here's another kind of tricky one. I'm going to do that long division type idea again on this one. We'll see what we get. Okay, so in this case, I'm going to have the 6x squared plus 7x plus 5. I'm going to divide that by 2x plus 5. I'll just give you a hint, this one's not going to work out quite as nicely. What do I multiply this by to get 6x squared? Well, my answer is going to be 3x. So 3x times 2x is 6x squared. 3x times 5 is 15x. Next step, remember I'm subtracting, but I like to add the opposite, so I'm going to change those signs there like that. And then when I add them up, those are gone. 7 minus 15 is negative 8x plus 5. And now I ask myself, what do I multiply this 2x by to give me negative 8x? And sure enough, it has to be negative 4. So I multiply those out, and I get negative 20. Once again, I'm going to change my signs here because I'm subtracting. That's a plus, that's a plus. And so what I end up with then is 25 down here. Now I run into a little problem because what can I multiply 2x by to give me 25? I can't. So we call that 25 then is the remainder. So that's it. And so that's my answer. My answer would then be the 3x minus 4. And then I might say remainder of 25, or I might write it as a fraction. All right, kind of tough stuff, but that's what this next lesson's about. So we'll see you guys in class tomorrow. Bye now.